we have always started with parent functions. So there's going to be nothing different here when we're graphing radicals. So we're going to start with the idea of parent functions. So here's what I would like you to do. For the square root function and for the cube root function, I would like you to fill out the table of values. I would like you to see if you can plot a graph, and I would like you to determine what you think the domain and range is for those graphs. So try those, and then we'll go from there. So, go.
0, 0.
Start with the square root of x, and let's fill in the values. When I plug in 0, what do I get? 0. When I plug in 1, what do I get? Ethan.
What?
Turn it down. Off. What do I get?
1.
What do I get when I plug in 4?
1.
And 9 I get. Okay, why did I make this table of values this way? Why does it not go backwards? Why are there not negatives?
Because that means it's going to be an actual function.
Can we take the square root of a negative?
No.
No. Okay, that gives me a clue as to my domain. We've actually already talked about domain of square roots quite a bit this chapter. Okay, plotting the graph, I'm going to move to a blue just so you can see it better.
I don't remember what we did yesterday.
0, 0, 1, 1, 4, 2, 9, 3. Hey, you guys, let's stop talking, please. All right. What is the domain? Is it all reals?
Yeah.
No, it cannot be, because all reals would indicate we can plug in negative numbers.
Well, we can't do that.
From 0 to infinity or anything greater than 0. You can say it either way. Whoops. I don't care which way you say it. You can use the inequality notation, which would say x is greater than or equal to 0, or you'd use the interval notation. What about my range?
It's got to be infinite. Infinite.
It is the exact same thing.
No cap.
So it can't keep going down?
I guess not.
Okay, there's a lot of side conversations, and we are going to go through these notes. And you are going to have assignments on these notes today.
What kind of assignments?
Yes.
So the y, it doesn't keep going down, it starts at 0?
It starts at 0. It does not keep going down.
It can only go up.
It can only go up.
This is graph like this. Right on.
Okay, what about cube root? What do we know about the cube root of negative 8?
It's got to be 2.
It's close. It is negative 2.
Really? I thought we can't do negatives.
You can't do negatives in even roots, but odd roots you can.
-2.
What about negative 1?
I mean, cube root.
1.
Negative 1.
2 times negative 2
Cube
times negative 2. Is it?
cube root
It's got
of 0.
0.
Cube root of 1.
1.
Cube root of 8.
2.
Okay. Is there any number that I can't plug in? We just showed we could plug in negative numbers. We just showed we could plug in 0. We just showed we could plug in positive numbers. Is there anything I can't plug in?
Maybe.
So that means my domain is what?
All real numbers.
All reals. Now, when I go to graph this,
Weird curve.
it is a kind of a funky curve, like an S. All right, what about the range?
Infinity.
It is also all reals.
Same thing.
Okay, now, these are apparent functions, which means that everything can come from these. This is the basis of our parent function or our shape of our graph. So now let's talk about our function transformations, and let's review those. Okay? Function transformations. These are the things that we have done since the beginning of the year. Remember, my A value, this A value that's in front, that stretches my graph or it shrinks my graph. We would say it's like slope, except these are curves. They're not lines. And remember, if we have a negative a, it flips the graph about the x-axis. H, what's inside moves the graph left and right. What's outside, this k
down.
value moves it up and down. They are the exact same a, h, and k we have looked at for quadratics. What else have we graphed?
Oh, the quadratic formula.
Yes, parabolas for quadratics. We've graphed radicals. We've done absolute values.
It's done a lot of graphing.
We've done a lot of graphing, and it all uses the same values. Okay, so let's look at some examples of how we would go through these problems. The first thing I'm going to caution you on is to pay attention to what your index is.
So you're moving it down 5.
You will not be asked to graph anything but a square root and a cube root right now. Going forward maybe, but not now. Okay? So we've got, the first thing we need to know is that we're dealing with a square root.
It's dumb.
A square root is important because that tells me that my parent function is that half of a parabola turned on its side. When we see the square root of x minus 5, with the minus 5 not inside the square root, what is happening to this graph, Joel?
It's going down 5.
This is being shifted down 5. If it helps you to start with your parent function, start graphing your parent function. So we have the points 0, 0, 1, 1, 4, 2, 9, 3. Those are our parent function. I'm going to graph those in gray. You have it right up on here. That's your parent function. That's the name, parent function. So our parent function, I'm going to start with that. But then I'm going to take everything based on what Joel said. I'm going to go down 5. Do you agree with Joel? Down 5. So I'm just going to take each of my points and shift them down 5 to
Just on the x-axis.
just the y values. Okay.
No.
A couple of important things about this graph. 1, if you make this come down here, or you draw an arrow down here, you will be marked wrong. There cannot be an arrow back here. This is my starting point. This is kind of like the vertex is to a parabola. It cannot go beyond that. That's it. My graph can move up and over, but it cannot go below that point unless there's a negative sign in front of the whole thing. Okay, let's talk domain and range. What's my domain on this one? Think about all the x values I've graphed. X is greater than or equal to 0. You may write that as that, or you may say 0 to infinity. They mean the same thing. What about my range? Jack says y is greater than or equal to -5. Do you guys agree?
Jack's always right.
Is he?
Yeah. Is this wrong?
That's right. This one.
Proves our point.
Does it?
Yep.
He gets 95s and above every time.
But
Yeah.
95s would indicate there's mistakes.
Listen,
I trust him more than I trust
it's got to be the grader.
There we go.
It's got to be the grader.
All right.
Yeah, seriously.
The grader.
Yeah,
Mhm.
my tests
We'll go
are
with
all-
that.
They're all fun.
Uh-huh.
Just kidding. I'm taking. Got pre-tests, huh?
All right, let's try the next one. Notice this one. Pay attention, though, because this is a cube root. And why that's important is because it means that my parent function is actually going to look a bit different. So if it helps you draw your parent function first, I'm a visual person. I like my parent function on my graph.
You could just move it right every one. Right?
Okay? What?
Right one.
Oh, no,
How
it's
is
just
this
like
parent function
extended.
shifting?
Every one you can just do
Based on the graph, what is that x minus 1 inside the radical telling me to do, Joel?
It's going right 1.
Right 1.
Yeah. No.
So now I'm going to take each of my points and I'm going to shift them. Well, let's go to the right.
I'm confused.
So the parent function is the foundation, the basis of the
obviously.
graph. You have to go right 1 is whatever it says. So you just move every point.
Is that right?
So we move it right 1, and there's the shape of my graph. Now, what's the domain?
Domain, it's gotta be
All reals. What's my range? That's the beauty of the cube root. Even if my graph has shifted, even if there are transformations, or even when there are transformations,
Always.
my domain and range will be all reals. Because I can plug in negative numbers, I can get negative numbers back out. All right, let's look at one that's stretching, and then I'm going to have you guys try the rest.
Stretch, wow.
Stretch by
So you're
2.
going left 4, down 1, stretch 2.
Okay, do you remember?
Left 4, down 1.
Okay.
Do you remember your order of operations when it comes to graphing?
Left 4.
What is most important to
Down
do
1.
first?
0.
The stretch. We need to take care of this stretch. So, I've heard several of you say stretch by 2, left 4, down 1. I agree. Let's look at what that looks like for the parent function.
I think I know.
Okay.
You're going to stretch it up on the y?
Remember with a stretch, the only value that's changed is the y value. Nothing else is going to be impacted yet. So if I want to deal with the stretch, I'll do the stretch in a different color just so you can see it. Let's do the stretch in pink. So let's stretch it by 2. Every y value is now going to be multiplied by 2. This first y value is 0. 0 times 2 is still 0. Then 1 multiplied by 2 is 2. 2 multiplied by 2 is 4. And 3 multiplied by 2 is 6. If all I had was the stretch, my graph would be the pink one.
Gotta go
So if
down.
all I had was that stretch, that's all I would be doing.
That's legit.
But I need to go now left 4, down 1. I'm going to do that all at once, and I'm going to use the pink point. So I'm going to go left 4, down 1. Left 4, down 1. Left 4, down 1. Left 4, sometimes counting on this is a little bit tricky. Down 1. I was at 6, now it should be a 5. Okay. Now, my graph cannot go below that point that has a left 4, down 1. Make sure you pay attention to the fact that I cannot go below this point. There is no part of my graph that goes below this.
Oh, yeah, so it's.
That's kind of like the
-4 to
vertex.
Infinity for the domain.
Domain would be what, Joel?
-4 infinity.
-4 to infinity. Do you guys agree?
And then -1 to infinity for the range.
Very good. My domain would be -4 to infinity. My range would be -1 to infinity. Or if you wanted to say x needs to be greater than or equal to -4, y needs to be greater than or equal to -1, you'd be correct as well. So parent functions, they're important. All right, there are 3 problems left of graphing. I want you to try them. Try the 3 problems.
Young kids.
All right, here we go. Let's look at this cube root. Can you explain to me what has happened in this one? It flips. That's the biggest weird thing with this one. So this graph is flipped upside down. Again, that's like the A value, the stretch or the shrink. We want to do that first. What else has happened?
Oh, you didn't have a video. That's a
No way.
Yeah. It's a Walker's New Jersey.
This is outside of the radical, so this needs to go up too. So my parent function looks like this.
Wait, why is it up?
It's not inside the square root or inside the root. It's a cube root. It's not inside the cube root. It's outside. So it's the k value. The flip. I'm going to do the flip first. And I'm going to do that in pink. So when I flip it,
I thought the flip was up or down. I mean, I thought that 2 was up or down.
it is a.
Oh, what's the flip? Oh, negative. Okay.
There's my flip. Now I'm going to take this flipped graph and I'm going to go up to.
How do you flip it? Just flip the sign to negative.
Yep.
It'd be a negative, or if it's a negative, it'd be a positive.
Yep.
Right on.
There it is. What about domain?
All reals.
All reals. What about range?
All reals.
All reals. It's a cube root graph. So the final graph is the blue graph. It has been flipped and it has been shifted up 2.
No doubt.
All right, let's look at the next one. This one's going to be a bit messier. It's not quite as pretty. So tell me what's happening with this one.
You gotta flip it, you gotta 1/2 strength, and you gotta move it left.
Okay, flip. It's shrink by a half. And then which direction does it move?
So it was left.
Left.
1.
1. Okay. I can deal with the flip and the shrink at the same time if you'd like. We can deal with them separately. I'm going to start with my parent function. 0, 0, 1, 1, 4, 2 because it's a square root, 9, 3. Flipping it and shrinking it by a half. Multiplying everything by negative 1/2. 0, 0 is not going to change. The next point's going to be negative 1/2. The next point's going to be negative 1. The next point's going to be negative 1.5. So this graph is really tight.
Did you flip it at the same time?
I flipped it and did the 1/2 at the same time. I did the flip and the shrink by 1/2 at the same time. Those are both part of the A values. A values need to be treated first. If you want to take it in 2 steps, that's fine. 1 step is also fine. And now I'm going to shift everything to the left one. Makes it tricky to see. Okay, what's my domain? X is greater than or equal to negative 1, and my range is... careful.
Oh, wait, no. 0, y is less than or equal.
Y is less than or equal to 0. This is different because we're going from the bottom up. The lowest y value we could get eventually would be negative infinity. You may see this written this way as well. Negative 1 to positive infinity and negative infinity to 0 if you want to see it in interval notation. It's going down. All right, what about this last one? Tell me what's happening here. We got all the things happening here. What's happening here? Stretch by 2. Then left 1 and down 2. Which type of graph am I basing this on? Cube root. Oops. So cube root function. I'm going to stretch it by 2 first. So I'm going to take and multiply everything by 2. That would be the pink graph. And then I'm going to move everything left 1, down 2. I'm going to do that all at once. Left 1, down 2. Left 1, down 2. Left 1, down 2. Some of my points line up. Left 1. And my graph looks like the blue one. Domain and range. All reals. Okay, so how can we go from here to writing an equation? How do I take it from the graph to write an equation? Let me just zoom in so you can see the graphs too.
Well, you need to compare it to the parent function.
Okay, if I want to write a function that takes the square root of x and translates it to right 1 up. To right 1 up. What does that look like? Grayson, say it louder.
Root x minus 2
Plus 1 on the outside. For reference, if you take the SAT, ACT, it is possible that you see it written this way. Are those in fact the same?
I'm guessing so.
You're guessing so because I told you that would be the same?
Yes, they are.
They are the same. The advantage of writing the plus 1 that we call the k value in front of the radical is then you don't get confused what belongs under the radical and what doesn't belong under the radical.
Well, that'll mess me up with the stretch.
It couldn't, yes, if you're not careful, it could mess you up with the stretch. All right, next one. I want you to write an equation for the next one. I want the next one to have a vertical reflection and go up 6. So what does that one look like?
Be negative.
Vertical reflection and up 6.
Really?
That's just up and down, negative.
Yeah, vertical reflection just looks.
Came back
So
from one day
negative.
and said, like, shit.
All right, what does this one look like?
That
No
actually
sign for
pretty good.
Is the plus 6 inside or outside?
Outside.
How'd we do?
Good.
Questions on this?
Math Excel or worksheet?
You have a worksheet.